Good morning, everybody. I'm hoping you can all hear me. If you can give me a wave, Sam, just to check that that's coming through. Okay, thank you. So, good morning, everybody, and welcome to this event organised by Triple Point Heat Networks Investment Management as part of the HNIP programme. Today's event, as you know, is about heat pumps in heat networks. Can move on to the next slide. And as the slide says, my name's Andrew Cripps. I work for Triple Point. I've been involved with the HNIP programme from the very beginning. We can move on to the next slide. Thank you. So, why are we holding this event? So, I'm assuming that people know by this point, several years into HNIP, everybody's now familiar with what HNIP is and what we're trying to do. So I'm not going into the broader details of it. But just to summarise, because it's quite important to why we're here today, the overall role of HNIP is to support the delivery of heat network schemes. We're providing funding from government money, from taxpayers' money, to help to make heat networks happen that wouldn't happen otherwise. You'll know, if you've been following the press releases, that Sam and the others from the GemServe team have been putting out over the last years about the schemes we've supported, and you'll be hearing about some of them today. We've got over 30 schemes in different stages of development, and you can read about them on our website. In parallel with that, we're seeking to increase understanding of heat networks. We all know, and you'll be hearing a bit more about the importance of heat networks in the future decarbonisation of the country, and part of HNIP's role was to help to get out there and help people to know about heat networks so that they're more understanding and accepting of them when they come along. And it's been great to see the recent high-profile media coverage. You feel when your projects have appeared on the One Show that you've really arrived in the world. Linked to this is the need to grow capability and experience. We had a relatively immature heat network sector, not completely. We had good schemes going on before and a base to grow from. But we all know if the future's to be the way we think it should be, we need a lot more capability and experience to help deliver all the schemes in the future. So those things have all been fundamental to HNIP, but there's a broader aim. This is picked up at this session, which addresses the last two of these points. We need to share lessons learned, and we need to plan for the future. So particularly delighted that today's session's happening. We have the opportunity to learn from people who are trying to do these things or are doing these things, and there's no better way, in my view, to help to improve our understanding for the future than to learn from what people have done already. In addition, and we know very much and come back to in a moment, heat pumps feel like they are a big part of the future, and we need to get ready to deal with them and the challenges associated. I can move on to the next slide, please, Sam, Christina. So we've been, I think, amazed and delighted by the rate of change over the last few years. The slide shows the proportion of the HNIP applications which are heat pump led. So in the first round, the pilot, there was a small percentage. There was one of all of the schemes that's going ahead, and that's grown quite radically. So that by now, the last year of the scheme, actually, the majority of schemes coming forward now to HNIP are based around heat pumps. Now, we didn't expect this to happen as fast. We expected it to happen. We expected there'd be early on, there'd be lots of gas CHP schemes which would have plans to convert to heat pumps over, 3, 5, 7, 10, 15 years. But actually the world's moved a lot faster, which is great in a lot of ways, but it's also throwing up some challenges. We can move on, please. So building on this, similarly, this is reinforcing the point. There's a database produced on behalf of BEIS called the Heat Network Planning Database. That's showing essentially the same message, that more than a third of the schemes in there, district heating schemes, are heat pump based, and quite a few of the gas schemes are intending to include heat pumps as well. And the slide on the right shows predictions around the growth of heat pumps. I think most of you will know that this is a coming technology, if not the coming technology. We can debate that as we go along. It's certainly got a part to play. We can move on. Thank you. So just so you know, all of the schemes listed on the left are being supported by HNIP, and they all contain heat pumps. There are some others which I can't show you yet because they're not quite in contract. Hopefully we'll be able to announce those as well soon. And as the map shows, they're spread across the country. And you'll be hearing from several of these projects today, so I don't want to spoil their stories any further. We can move on. And a really important part, as I'm sure you all know, is that heat pumps can take heat from a variety of places. And within our group of projects, we've got schemes taking heat from rivers, from sewers, from the ground in closed loops, and from mine water, and of course from air. And you'll hear about a range of these today. They're all part of the solutions for the future. So it's great to have a range of things being tested and learned from as we go forward. We can move on to the next slide. So this is a slide really beginning to introduce some of the challenges. I know that Simon will be touching on some of these as well, and then you'll hear about it from the different projects. Where next for heat pumps? The diagram on the right I found in an excellent report produced by IEA Annex 47, which is looking at heat pumps in heat networks. A lot of good work there, and really recognizing there are a range of issues which we recognize and are part of the reason for the event, and to think about where we go with this. So obviously heat pumps have a different financial arrangement from gas CHP schemes or energy from waste schemes. We need to understand that, particularly in the post-RHI environment, how they can work. Similarly, and I'm sure this won't come as a surprise to people here, the operational temperatures, losses and efficiencies of systems, these are all really important characteristics which we need to understand in our processes. Do we have all the right optimized solutions? We have a challenge, particularly with existing schemes, in terms of integrating heat pumps with other technologies which operate in slightly different ways. It's not that these things can't be resolved, but they are additional engineering challenges. Something which I think is going to come to the fore more is what the contractual arrangements may be with people who have the sources of heat. So we're looking, as you'll hear, to take heat from wherever we can, particularly if it's of a higher temperature, and therefore we need to engage with new players and make sure that those contractual arrangements are fair. An important dimension to this is in a period of rapid growth, do we have the supply chain that we need? Are the products available? Do we have the expertise to install them and maintain them? And how are we going to make sure we're growing that capability over time? And last but absolutely not least, probably most importantly, how are we engaging with this in this period with extraordinary fuel price inflation associated with gas and electricity? How are we going to manage the cost to the end users, both now and in the longer term? Now, we know full well that we can't solve all of these issues in one session, but we're hoping to explore some of these points and hear the views of the panelists and from you out in the audience. And one of the aims of the session is to recognise things which perhaps we can't fully solve today, but we could work up as agenda items for future events in which we can take some of these issues forward and work with others to try to find solutions. We can move on again, thanks, to I think my final slide, more or less. No, not quite. So this is the plan for today. You, I hope, have seen the agenda, but I'll just run through very quickly. I've basically finished my welcome and opening remarks. We're going to hear from Shivali from BEIS on some issues from a policy perspective, followed by Simon from UKDEA with his perspective and the UKDEA perspective on the challenges that these present of heat pumps in heat networks. And then we have presentations from 4 of the projects that HNIP are funding, all incorporating heat pumps in Liverpool, in London, in Worthing and in Bristol. And in between those, to break this up, we'll pause a couple of times to have a chance to respond verbally to the questions that we hope you're going to be posting. We can move on to the next slide. Just to remind you that there is a little button at the top of your screen with a question mark. If you click on that, it'll take you to the Q&A panel, and you can put in the questions that you'd like to ask the panel. You can make them specific to an individual if you like by adding their name, or you can just pose the question in general. We'd really like to hear from you. We're delighted to be able to hold seminars in this period, hopefully the end of COVID, but it is a bit dislocating for us because the feedback's indirect. So it's a really good way for us to know that you're there and interested, and the chance to engage with you. And we'll try to answer those questions either by replying in the text box, or they'll come through in the panel discussions. There may be some questions we can't answer. We may take some things away to bring back to you in a future seminar. And there's also a survey here which we would like you to fill in with comments, which you may or may not have on this event. So that's all I wanted to say. So I'd like to pass over to Shivali from BEIS to give us a bit of background in terms of the BEIS perspective on this and the policy environment.
Thank you, Andrew. First slide, please, Erin. I'm Shivali Mathur from Heat Networks Department at BEIS. Heat and Building Strategy got published just before COP26 last year, setting out a clear role for heat networks. So I've taken a couple of quotations from the strategy document, which are highlighted here on the slide. Heat networks are proven scalable options for decarbonizing heat and will play substantial roles in any net zero scenario. So we need to build the market for them now. The second one, which I wanted to share here in the forum, was heat networks will be a key technology in areas of high density heat demand and where there are large low carbon heat sources. This document on heat and building strategy builds on the Prime Minister's 10-point plan and the Energy White Paper, which was announced in 2020, to provide a clear direction of travel for the 2020s, demonstrating how we will meet our carbon targets, ensure that we are on track for net zero, and rapidly support the jobs and leveling up. Last year, leading up to COP26, we also published a comprehensive net zero strategy, which is a cross-sector strategy aiming to set out government's vision for transitioning to a net zero economy and making the most of new growth and employment opportunities across the UK. We hope that this strategy, along with the other documents that were released last year, will help to raise UK and global ambition to tackle climate change by decarbonizing the buildings. COP26 really heightened interest in this area. Next slide, please, Aaron. So why heat networks? We have next slide, please. Thank you. So why heat networks? Heat networks take heat or cooling from a central source and they deliver it to a variety of different customers. As you're all aware, to public buildings, shops, offices, hospitals, universities, and homes. Heat networks have the potential to reduce the bills, support the local regeneration, and be a cost-effective way of reducing the carbon emissions from heating. They can unlock otherwise inaccessible large-scale renewable and recovered heat sources, such as waste heat from industry, heat from rivers and mines, as well as providing cooling in changing climate. They can interact with the energy system more effectively in some places than building level solutions through load shifting, demand side response, and economies of scale. Currently, there are approximately 14,000 networks in UK, 2,000 district and 12,000 communal networks. That covers 2 to 3% annual UK heat demand. The scenarios in clean growth strategy suggested that heat networks could provide 17 to 24% UK's heat demand by 2050. An interesting number over there is the investment potential, which presents between 13 billion and 22 billion pounds by 2050 and is considered a heat networks investment opportunity in Europe. Going a little bit on, as Andrew mentioned, about government's work on HNIP or in heat networks. Sorry, next slide, please, Aaron. The Heat Network Transformation Program. As part of this, since 2013, we had set up a heat network delivery unit. The purpose of this unit has been to support the local authorities in England and Wales through the early stages of heat network project development, the heat mapping, the feasibility studies, the detailed project development. We have given out a total of 23 million pounds of grants through HNDU across 150 plus local authorities, over 250 plus projects. From 2017, we had HNIP, and Andrews mentioned the Heat Network Investment Project earlier, but very quickly it offered the gap funding to heat network projects in commercialization and construction funding. Again, the idea to accelerate market growth. In March 2020 budget, the Chancellor announced funding for the creation of Green Heat Network Fund. The targeted successor of HNIP. The Green Heat Network Fund is intended to facilitate the transition towards low carbon heat generation in heat networks across England. The fund is planned to open in this year, 22, and close in 2025. We launched the Green Heat Network Fund Transition Scheme on 21st of June. The purpose of this scheme was to better ensure that low carbon heat network projects are construction ready in time to apply to the Green Heat Network Fund full scheme, which opens soon in the next financial year, that is April 2022 to March 2023. Powered by a Green Heat Network Fund, why is it important for heat pump-led heat networks as well, is it incentivizes heat networks to move from fossil fuel heat sources and help achieve the target of net zero carbon emissions by 2050. The funding is planned to be available for a range of technologies that facilitate decarbonization, including large-scale heat pumps, solar thermal, waste heat recovery systems. Really important is compliance to local air quality limits. Another important piece of work which we're working on, the Energy White Paper committed to introducing heat network zoning by 2025 at the latest. We stated in our 2020 consultation of building a market framework that we would trial heat network zoning. Since then, we have launched the city's decarbonization project to look at how the heating systems of 6 cities across England could be decarbonized. We agree with the industry and local authorities that zoning can play a significant role in growing the sector by reducing the risk, ensuring the investment, and increasing the speed of deployment. Last but not least, the initiative of HNS, Heat Network Efficiency Scheme. This demonstrator has the objective of achieving fuel and carbon savings in existing networks, improve the customer outcomes in existing networks, and build an evidence base to inform the heat network policy, helping to prepare the market for future regulation and standards. Erin, next slide, please. A little bit on innovation. I hope it's visible, but the sunburst on the right side of the slide provides a very quick understanding of the technology area. These 2 charts have been taken from a report published by IPO Office, Intellectual Property Office, later last year. So the sunburst on the right, it shows, gives an understanding of technology area, includes the categories of inventions that are protected and in what proportions. It shows around 46% of greener building patents relate to electronics, 5% relate directly to buildings. What it suggests is that greener building developments is more focused on technological advancements and uses of electronics. 17% or around 17 to 20% of patents relate to heating, suggesting that heating of homes is a significant focus with greener building patents, like smart home heating technologies. When we look at the worldwide picture on the left side of the chart, the growth in the number of greener building patents has been steadily increasing from 2001 to 18, suggesting that technological development in this area has been going on for some time and is continuing to develop. Getting again back to the heat pumps, considering the worldwide landscape of patents relating to heat pumps, this area has shown a significant increase in patenting technology, especially in recent years than in 2000, which suggests to us that there may have been an increase in R&D relating to heat pump technology in recent years. UK government is seeking to develop low carbon buildings in coming years and increasing the use of low carbon technologies such as heat pumps may be means to achieve this. Green Heat Network Fund supports the commercialization of low carbon heat network projects, and it may support the use of more low carbon technologies in the rollout of heat networks. Mindful of time, I think I'll go through my last slide. Erin, please. Andrew mentioned briefly about the HNPD, the Heat Networks Planning Database. The idea behind this was government supports the growth of UK heat networks market as a crucial part of UK's heat decarbonisation journey. Providing accurate information on the market and signposting upcoming projects to investors is essential for developers and other partners within the heat network supply chain. So HNPD provides you a picture for both district and communal heat networks deployments across the UK. It enables increased pipeline visibility of projects in the planning stages, especially the ones which do not receive government funding. It also enables insight into the deployment of different technology types, air source heat pumps, biomass, gas, CHP, ground source, water source heat pumps, and it gives greater clarity over upcoming projects. Interestingly, it tracks the progress of projects through multiple stages: inception, planning, construction, operation, and decommissioning. Baba ABI has been collecting this data on behalf of BASE, and they've also created an interactive map to visualize the data. If anyone has any information about a scheme which is not included in the database or has any feedback, please do contact us at hnpd.inquiries@base.gov.uk. Thank you.
Great, thank you so much, Shivali. We're now handing over to Simon from the UK DEA.
Good morning. Hopefully I'm live, so if I can have the first slide, please. Okay, so hi, my name's Simon Woodward. I'm the chairman of the UK District Energy Association. Hopefully some of you have seen me before. The presentation this morning is about the issues and challenges of decarbonising heat networks in what we call the third age, the age of waste heat and heat pumps. So next slide, please. So firstly, a bit of an introduction about ourselves. If you haven't come across us before, we're a non-trade, not-for-profit association. We were actually founded by 6 local authorities way back in 2010. We're growing rapidly. We've got over 130 members, 30 joined in the last year, and we represent all major district energy schemes across the UK. At the core of the scheme developers and owners, those are the full members, the people who face the pains of investing or owning district energy schemes every day. And around the outside are all of the very important people who are also in the sector, the installers, the equipment suppliers, service providers, etc. Next slide, please. So what do? We give members the tools and the support they need to develop their schemes. We're a very respected voice for raising concerns to government. We meet with BASE officials weekly, often daily it seems these days. We issue a monthly 50-page journal to all members. We have an annual conference and AGM, but we do have regular information and networking events. We have some incredibly successful webinars during 2021. We had over 250 delegates at our last one, which was about the practical application of heat pumps. That was very successful. We've got a feature about website, library for members, a training register, help, advice, support, lots of other features. And we're a network of organisations working together to assist each other as a voice for the sector. So next slide, please. Thanks very much indeed. So I think it's important to have a bit of a history lesson, because although we're all understanding that heat pumps need to now play an important part in district heating networks, I think it's important to understand why this has happened and where we started from. So just looking back in the past, back in the 1960s and 70s, what we call the first age of district heating. District heating schemes were installed largely to sell coal, sell oil, to bring the concept of one centralised efficient boiler plant, operating and delivering heat to a network, and many heat networks were just promoted on the efficiency that delivered. And as you can see on the right, way back in 1971, so we're talking 50 years ago, the government was encouraging people to build district heating networks. So this is not a new idea, far from it. The technologies that we're using to deliver them and heat them are different, but not the concept. The problem is, back in that time, lots of networks were failing, high heat losses, poor efficiency, and therefore in the early 70s and 80s, we were talking about decentralisation and removing heat networks. But fortunately, by the late 1980s, it was clear that we were building a new breed of reliable heat networks. And I think the importance of this history lesson is that things have changed over the last 50 years. And what we're doing at the moment is embracing another big change in the sector. So next slide, please. So we moved into the second age, and the second age lasted for quite a long period, I would say from 1990 to 2020 largely. The second age was a growing understanding that you could deliver high efficiency heat networks, and a well-designed large-scale heat network should have low heat losses. So I think that's important to differentiate between the heat losses in a primary network and those in a poorly designed secondary network in a residential building. And there was a widespread use of gas-fired CHP, and that's what we call in the UKDA the financial viability engine for heat networks. And the issue we've got at the moment is the financial viability engine for heat networks is broken, but we'll come on and talk about that in a moment. And there were many large schemes delivered using gas-fired CHP, Birmingham, Leicester, Olympic Park, etc., during that second golden age of district heating. So next slide, please. So by the end of the second age, the problem we've got is that we've got the carbon intensity of the grid dropping, and although CHP remains the only replicable viable carbon heat source for heat networks, the carbon benefits have reduced as power generation becomes lower carbon. But we believe that if you analyse CHP on marginal carbon factors, that it still makes sense, CHP still makes sense. Well, I don't think we're quite clear on the government's position on gas-fired CHP. They claim they support CHP as a transition technology, but the signals are a bit confusing. But I think we've got to recognise that whether the signals are confusing or not, we are moving from the second age where CHP was the technology of choice into the new third age of district heating. So next slide, please. So 2020 to 2030 and on to 2050, I think it's really important that gas-fired CHP has some form of role to play as a transition technology. The government has acknowledged that in its recent interim uplift to SAP, but the landscape is changing. So we don't have that simple solution that we've had for the last 30 years of plugging a gas engine into the gas network and using that to power a heat network. And in many cases, it would involve waste heat, but the problem is that there are many different heat sources that you could select to power your heat network when you use waste heat. And I think that is the real problem moving into the third age. We don't have a single technology solution, a primary front runner as we did in the second age. We've got a multiplicity of heat sources that we're moving forward into the third age. So next slide, please. So a question that's often raised, particularly when people are talking about in-building solutions, is why are we even bothering with heat networks in the third age? Why haven't we just abandoned them? We've lost gas-fired CHP. It doesn't make sense anymore. Why don't we just put low carbon solutions in each building? There are certainly some in the sector, not our sector, but some in the whole decarbonisation sector thinking that's a good idea. My view is that heat networks have a really, really important role to play, but only if certain things happen. So that either they're using a heat source which is accessible at a single building level, could be any big energy from waste power, it could be industrial waste heat, it could be waste heat from data centres, or when it's used to bring efficiencies or financial economies of scale, which overall lower the cost. Overall, they deliver a better carbon solution. So that's either through an improved heat pump CHP, it could be removing the need for widespread grid reinforcement, or it could be because as many schemes did, large schemes using gas-fired CHP combined heat loads at different times of the day, the week, dwellings, commercial, etc. So there are certain scenarios in which heat networks are a very valid and important tool in the box to bring about decarbonisation of urban areas. But I think it's important to ensure that you're ticking the boxes on these slides if you're delivering heat networks, because if you're not, you might want to question why you're doing it and why you're not doing individual building decarbonisation. So let's move on, please. Next slide. So this slide is a busy slide, and I don't intend to go through all of it, but I think as you're getting the slides, it's important for you to understand there are lots of issues with utilising these new energy sources, which didn't exist when you had gas-fired CHP, and we're working as an association with BEIS and others to overcome them. There's a lack of incentive. There's no drivers. There's no policy to encourage waste heat owners to put their waste heat into heat networks. There's no support mechanism. It's also low value. That's one of the main problems we see across the sector because it's low value, because waste heat needs to be sold at a low value in order to be try and deliver some financial viability when you put it through a heat pump. It's not very attractive for that end user to sell. Often it's very remote from the customers that you're trying to supply, and often people are trying to bias their plants to generate more electricity to heat. A number of other issues on the slide: contract period, you've still got to put in place all of the backup boilers, those have got to be located and found. And there are two different types of waste heat source. There are those at a temperature that could be used directly without a heat pump in the top of the slide, energy from waste, high temperature industrial waste heat, or the vast majority of sources, those lower temperature sources which do need heat pumps: air, ground, boreholes, river, sea, wastewater, etc. And just that list signifies that each of those needs an individual consideration, and they each bring their problems with them. Next slide, please. So I think what I'd like to summarise is, are heat networks viable in the third age? I think high temperature waste heat, this is our view, with commercials that work, let's say a penny to penny and a half kilowatt hour, I think it's possible. Low temperature waste heat with no renewable heat incentive, and very importantly, and this is a really key point, heat charges set against a gas-fired boiler counterfactual, even with a significant capital grant, that's no. The problem is we've lost our HI. If you are trying to sell heat under a long-term agreement to develop your heat network and set it against a gas-fired boiler counterfactual, and you're having to put low carbon waste heat in at low temperatures and then put it into a heat pump, it is very, very hard to make those work. So what do we see as the solutions? So we see the solutions are a low carbon heat network incentive, similar but not the same as the RHI, to act as a bridge until customers accept that a gas boiler counterfactual is not correct, and heat charges have to rise to reflect decarbonisation of heat. Next slide, please. So we're currently working hard on a number of policy proposals, detailed policy proposals. We've got detailed modelling that we're working on with BEIS to address these issues, and we would welcome you to come and join our conversation that we're having with BEIS. So please do get in touch and become a member. Thanks very much indeed for listening. That's me over.
Thank you, Simon. We're now going to hear from James Hadfield from Innovate.
Morning everyone, my name is James Hadfield. I work for Innovate. Innovate is a consultancy offering a wide range of services linked to district heat networks, from financial modelling to funding applications and escrow asset management. We specialise in the commercialisation of heat networks and how they can be delivered effectively. Myself, I'm a development manager, so I take projects from initial feasibility through to construction. And I'll be talking about Liverpool Waters today. Liverpool Waters is Peel's waterfront regeneration scheme in Liverpool. It's 9,000 residential units and all the commercial space that you'd expect to go along with those. Our client, Peel NRE, has chosen to attempt to provide heat and hot water to those dwellings via a water source heat pump, and I'll be talking about that journey today. Next slide, please. This is a plan showing Liverpool Waters and some of the satellite developments around the project. For orientation, the left-hand side is north and the right-hand side is south. The red line represents our current pipe run. So moving from the right-hand side there, where it says phase 1C, that area is currently in feasibility at the moment, being assisted by HNIP funding. Moving left, where it says phase 1A, we're actually installed in that location and ready to go, all the way up to where it says temporary energy centre, where we're mobilising for construction at the moment. Then moving up from there, where it says phase 1B, we've actually got an active network in that location being fed by a temporary energy centre. And then up from there, where it says phase 2 energy centre, we're lagging a little bit behind there. We're in procurement at the moment, but what we do have is planning permission for a 6 megawatt large scale water source heat pump with gas backup at 40 megawatts. The water is to be abstracted from the Leeds Liverpool Canal, which is just north of the site there, and to be re-injected into the dock system where it's labelled phase 2. And this plant, it spans roughly 2 kilometres, so it's a large scheme. Next slide, please. So what I wanted to discuss here is that these projects are long-term. They take a long time to get off the ground. I've been working on Liverpool Water since 2017, and during that time we had to make some tricky decisions around getting on site and getting some pipe in the ground ahead of some other programs that were progressing, such as roads, or perhaps you might be needing to get some connections into your retrofit accommodation. Maybe their plant is at the end of its life or something like that. So we were on site quite early trying to get ahead of these things, assuming that we were okay with a CHP-led energy centre. But NFA noticed on the horizon that there was potentially going to be some changes to building regulations, and we advised the client that probably if we continue with the CHP design, we're going to have a product which is too carbon intensive for us to offer that in an attractive way to the new build developments on Liverpool Waters. So luckily the client agreed with us. They made the bold move to come along on a journey to try and figure out how we're going to decarbonise that heat at the energy centre. We went through various different options working alongside Arup and Vital Energy, and we concluded that a heat pump was the way to go. Looked at all the different options available to us, and given the amount of water that surrounds the site, we went with a water source heat pump. So what I want to say really is these are really long term. You've got to keep an eye on policy. You've got to make sure you don't trip yourself up with the product that you're going to offer to new build customers, and that district heat networks are really good in the way that they are plug and play. We had to go ahead and install some pipe, but that pipe did not need to be changed, even though the heat source was completely changed as a result of our redesign. Next slide, please. The other issue that you have with such extended programs is that you need to go ahead and get planning for a scheme that's going to cater for everyone. So it's a bit speculative because you need to include all the satellite developments that you want to be included within the scheme. But you can't turn up on day one and install all of that infrastructure because it just screws your financial model. You've deployed far too much capex up front. So we had a long think about how we were going to deal with this, and what we came up with is like a modular approach where you can get going on site pretty early with a gas sort of gas-fired initial energy centre that you can see there top left, and then as you work round the screen you'll see that we add in a heat pump and a thermal store to make sure we can use as much heat from that heat pump as possible. And then bottom left you can see there's an additional heat pump, an additional thermal store with additional gas backup, and then bottom right we've got full build out with all the gas backup, a large flue, and all the heat pump infrastructure as well. So what you do here is you're deploying the capex across many years, ensuring that you're actually delivering the scheme in accordance with when the revenues are available. So more connections means more revenues, and you can deliver an additional module or additional kit on site. Next slide, please. So these sites, they're quite hard to come by really in cities, which is what we were dealing with. So you've got to make sure that your communications are on point and you're working out whether or not you're going to be able to deliver it in the location where it is required. So you need to speak to as many people as possible and communicate widely what you're trying to do. So the owners of the heat source, in our case, that was the Canals and Rivers Trust. You need to make sure you've got their permission to actually utilise that water. They've been very supportive in our case, working closely with us over a number of years. The public, you need to communicate widely with them because it can look like a bit of a power station in a city, which raises a few eyebrows. So you need to make sure they know that this is low carbon infrastructure. This isn't something that's going to poison the environment in any way, and it's something they can get on board with. Highways department, you're going to be digging up roads at some point, that's guaranteed, so you need a good relationship with them. And I suppose the main one I wanted to point towards is the utility providers. You need to be speaking to them as early as possible. Large scale heat pumps and all the backup infrastructure that's required can be power intensive and power hungry. In our case, we needed 4 MVA, and that is really hard to come by in Liverpool, where it's an SP constrained network. So we had to finesse that quite heavily to ensure that we could get that without having to pay, you know, £18 million reinforcement infrastructure costs and find some land for a new primary substation and all that stuff. So you don't want to go through a large, expensive design process without knowing that you can actually accommodate the infrastructure on that site. Next slide, please. So once you know that you've got a site that's probably going to work, you need to make sure that you get it into the planning process and you're successful in doing that. What you'll find is that you tick in a load of boxes in accordance with local and national planning policy. You know, you're going to be keeping a lot of people happy there, but you need to make sure that your air quality, noise, ecology and all the usual stuff is covered robustly, because you're going to be close to residential receptors. You're going to be probably in a city location, so you need to make sure that your air quality is not negatively impacted, especially if you're using gas boiler backup. So your flues need to be high enough to disperse any emissions in the correct way. Noise, heat pumps and gas boilers can be quite noisy, so we had to commit to beefing up our cladding a bit to screen that from our neighbours. And a tricky one for us was UXO considerations. We'll be breaking ground, and apparently Liverpool took quite a bombardment during the war, so we just had to be conscious of that, and we have to have a presence on site to ensure that that's covered and all mitigation, etc. is in place. Next slide, please. So here you can see the final design, and if you look on the left hand side, you can see 3D CGI. Yeah, and you can see the modular approach building up there. So bottom right, that's the initial gas boiler section. Moving left from there, where the roof gets a bit higher, that's where the heat pumps will be housed. At the back there, where it's a little bit lower again, that's where the gas boiler backup will be installed as the scheme develops and more connections are added. On the right hand side there, you can see the thermal stores. Just for scale, they're 12 meters high. And then on the left hand side, you can see the flue to cater for the emissions from the gas boilers. That in itself is modular as well. So it'll be 10 meters shorter than what you can see there until the wider site comes into use. That green section there, you can see at the back. Once that comes into use, we will add an extra 10 meters on. So right now, we don't know what that land's going to be used for. So it's all about just ensuring that we're future proofed and we're not becoming a constraint for the neighbouring site. On the right hand side, you can see we abstract in the north of the site, run it around the perimeter, so we're not a constraint for the wider site. The water is then utilised within the heat pump section, which is sort of the dark grey section you can see on the bottom left, and then the water enters the road, Sherwood Street, where it continues west towards the site, so it can be discharged within the dock system. Our DH pipes also share that same trench, so they go west in order to provide the heat and hot water to Liverpool Waters and other developments. Next slide, please. So in terms of next steps, we're in the procurement stage. This is another area that's being assisted by HNIP funding. In the absence of the RHI, we need to make sure that we're getting the best price on every element of the project, and that's become more and more difficult. Prices seem to be going up and up due to COVID and material shortages and labour shortages and other things. So we need to make sure that we're getting the best price possible, but we're sure we can get there. And once we do, it's our ambition to be building this thing over the next 18 months. Next slide, please. Thank you.
Thanks, James. Just handing over now to Jeff and Evangelos.
Hi, morning everyone. So I'm Jeff Laidler, an independent sustainability consultant working for Royal Borough of Kensington and Chelsea as their heat network programme manager. I'm working closely with Evangelos from Rambol on the technical design of the energy centre and of the primary heat network. Next slide, please. So the Nottingdale Heat Network, we're developing a zero carbon heat network at Lancaster West Estate in North Kensington. It's roughly a £20 million capital investment to create the zero carbon heat network, and that's part of a much wider refurbishment programme. So over £100 million is being invested in a deep energy retrofit of the homes on the estate. We're aiming to be nationally significant for a couple of reasons. So we're proving sort of the model of a zero carbon renewable heat network combined with that deep retrofit. So fabric first approach and then adding on the heat network at the same time to help decarbonise the housing, social housing in the borough, and the sort of the wider ambitions for the whole borough to be zero carbon. And then the second sort of element of making it significant, hopefully significant, is the resident co-design. So heat networks are complicated projects, but we're designing it in partnership with the residents and putting the residents first. So it's not just an engineering project, it's actually really remembering that there's going to be people on the ends of these pipes and making sure that it's going to work for them. So a couple of examples of what we're doing there is we've been co-designing a resident price promise, and we're also going to be working with them on the location and the design of our energy centre. And as a result of that sort of buy-in from the residents, we did a recent poll and 86% of residents are supportive of the project. So next slide, please. So a quick overview of the project itself. So we've got two ageing heat networks built in the 1970s, end of life, social housing, the council's the landlord, the controls on the existing heat networks are basically turn it on in winter, turn it off in summer, control it by opening the windows. There's definite room for improvements, and we're looking to install one new heat network for the entire estate, including the commercial loads or that are on the estate. So we've got an academy, school, we've got a leisure centre, and we've got some small business units as well. So one new heat network, and we've pulled together a business case that shows that it's technically and commercially viable at a relatively small scale. So it's only just over 800 homes. And with that significantly reduced heat demand due to the retrofit, and with predominantly social housing as the main customer. So we've got a business case that works. We can make sure we can achieve the ambition to get to zero carbon by 2030. And then really what we're showing here is that we're, although we're starting small, we're creating something that's going to be a launch pad for hopefully significant expansion. So we've got funding from HNDU to develop the business case for our expansion into Nottingdale Ward. And we're just about to start on the business case for that. We've got funding from the GLA, looking at a cross-borough energy master plan together with the neighbouring borough of Hammersmith and Fulham, recognising that both boroughs are densely populated, a significant expansion opportunity. And to deliver it, we're setting up a 100% council-owned energy company. Next slide, please. So from a sustainability perspective, we're covering all aspects of the energy hierarchy. So rather than connecting a renewable heat network to a load of leaky buildings, we're starting with the fabric first approach, and we're estimating we should deliver at least a 25% reduction in people's heat demand. So that's the lean element of the energy hierarchy. And then the clean and green is covered by the new renewable heat network. We're not planning to do any carbon offsetting, and to ensure that's the case, we're going to need to buy 100% green electricity. We're also maximising the amount of solar PV on the estate, which will be about 5 to 10% of the electrical demand, so local generation. Next slide, please. So I talked a bit about the resident co-design already, and it's really proving its worth. It's really sort of strengthening the project. Sometimes you can't see the wood from the trees when you're developing a complicated project such as this. Residents have come up with some great questions. That extra bit of rigour, it takes a little bit longer, but it's actually proving its worth as we work our way through. That includes 2 residents who are going to be board members on the new energy company, so taking that resident co-design through into co-delivery. Next slide, please. So in terms of how we're going to actually make this happen and make zero carbon happen, we're not blessed with any energy from waste plants. We haven't got any industrial waste heat. So we knew from the start that we had to consider environmental sources of heat. And we tested 3 options. Our preferred option for this core scheme is a large air source heat pump with an electric boiler. It works well for the scale that we're at. We haven't got any cooling requirements. It's free at point of access. We haven't had to obviously develop a heat supply agreement, and we've proved it's sort of technically and economically viable. We've also got a trunk sewer running under the estate, so we've been doing some sewer monitoring, and there's 1.8 megawatts of heat in that sewer. We're probably about 9 months in now with the sewer monitoring. There's someone that actually had to dress up in the scuba gear to actually get in the sewer to install all the kits. So it's positive, but to make that happen, we need a heat supply agreement with Thames, and it would require a significant capital investment as well as sort of taking up a significant amount of space for all the kits. So it's an option that we'll come back to, especially once we've got that year's worth of data, but probably more suited to a larger scheme. So we'll revisit that with our phase 2 expansion. And similarly, we'll have a look at the ground source heat pump opportunity with the London Aquifer. Desktop study says it's positive, but we'd need to do some borehole monitoring to take that to the next stage. And then finally from me, the next slide is just in terms of the timeline and how we're sort of transitioning across to 2030. So it's a bit of a phased approach. We can't go zero carbon from the get-go. The business model just wouldn't stand up. So as the refurbishment happens, we'll install the new secondary tertiary networks and still connect to the existing gas boilers. From 2024 onwards, we'll install our new energy centre, so it'll be predominantly renewable heat from that point, with some gas, keeping the existing gas boilers there for peaking. And then in 2030, we swap out the gas and put in the electric boiler, and at that point, we're then zero carbon. So I'll just hand over to Evangelos.
Hello. Hi. Thanks, Jeff. So on the technical aspects of the project, we looked at primarily 5 different scenarios as part of the techno-economic analysis to lead us to the preferred option. Those were a do-nothing option, where it was retaining the 2 existing communal heat networks with being refurbished through the refurbishment project and swapping out the existing gas boilers with new boilers, and the rest of the estate that is supplied by individual combi boilers, those to be upgraded as well with new combi boilers. The second one was similar to the first one, with the difference that the gas boilers on those communal heat networks were to be replaced by an air source heat pump, so 2 air source heat pump plant rooms installed on 2 sides of the estate, and the combi boiler supplying the individual houses, dwellings, was to be replaced by individual air source heat pumps. Third one was the decentralized heat network option, so an energy center with a large-scale air source heat pump and supplementary plant supplying the heat network and going to each buildings for this phase. It was a direct electric, so that was to remove completely gas boilers and everything from all the dwellings and replaced by direct electric heating. And as Jeff mentioned, the sewer heat recovery scheme, which is linked to the heat network. So that was looking to waste heat recovery from the sewers through water source heat pumps. Through that analysis, the preferred option was selected, and that was the air source heat pump led heat network. Few highlights from the design stage that was done, which was to answer the main asks that came through the co-design process and the requirements set out by the council for the estate. So we tried to make as much better use of existing spaces because of limited locations to build a brand new energy center. So multiple energy centers is the solution we went for. As Jeff mentioned, in early stages, we'll be utilizing some of the existing gas boilers from the Camelford Court communal heat network, which would be tagged into the heat network. We also had to look on how not to put any constraints on the Lancaster West Estate heat network. So that was a phase one of something that could grow further in the future. So we ensured that additional capacity is added on the main spine of the network to allow it to grow on the future phases. And that combined with the multiple energy centers approach would allow to introduce additional low carbon sources in the future, like the sewer heat recovery, ground source, etc., as the scheme and the demand grows. Next slide, please. So as mentioned, one of the key things that we looked into more detail was, and that was pretty much to make sure that we cover all the concerns from the residents. It was to look on what's the difference between when comparing having a decentralized and a centralized option. So can go to the next slide. We'll have the summary, the outcomes. So it was looking on the individual air source heat pump approach and the decentralized approach with the energy center and the heat network with a larger heat pump. As you can see from that table, pretty much on all the economic aspects, the heat network approach looked to score much better and giving a better benefit for the residents, so the end user. That way it was easier to allow for better performance out of the heat pumps by going for a larger scale heat pump. The only thing that the domestic approach was doing a bit better was on didn't have the heat losses that you inherit by the heat network from the pipe distribution pipe, but the whole design process was done on the back of following the requirements of the code of practice for heat network. So from the analysis and the design done, we made sure that we are within and below the margins, the acceptable margins for these heat losses. Also, the heat network approach opens the opportunity for grant funding to pay towards the capital expenditure of the project. So that has a benefit for the end users as well, in terms of, and which is reflected from the price promise. Next slide, please. So challenges / lessons learned from the project, as was mentioned earlier as well for the Liverpool Waters project. When you're looking to move away from gas and bring in large-scale heat pumps and decarbonize your heat, one of the key issues arising early is the grid constraints for the power supply on the local area. Most of the cities, towns in the country have this issue, so we needed to understand what is the capacity that we can get out of the grid, and especially the costs that are associated with that. So early engagement with UKPN was key on that, which led to the strategic budget application teams to commission an energy master plan for the whole local authority area, which will be supported with from UKPN. So looking on the future, how that can further improve and doesn't become a constraint for expansion of the network. Then installing a large-scale air source heat pump can raise lots of issues with local residents, from noise, visual impact. So that was a consideration we took from the start of the design process. So the solution we came up was that the roof of the laser center, which is central to the estate, could be utilized to install the air source heat pump plant room, so one of the energy supply points of the network. And again, early engagement with the planning team was crucial, so can be able to identify any showstoppers and try to mitigate those through the design. And finally, that could be a problem with heat networks, that you concentrate on the heat network aspect without paying attention on what the actual building needs. We were lucky on this, the way the whole process of the co-design was set out, that the heat network and energy supply design was informed from the outcomes from the refurbishment project. So that helped to the selection of the preferred option, and also the end product being an optimized solution, making sure that the whole primary, secondary, tertiary system, so the whole scheme, will be able to work as best as possible for what is required to. Next slide, please. So in summary, the new zero carbon Nottingdale heat network will put the residents first, so tackling fuel poverty, decarbonizing the heat, and providing affordable heating for the residents on the estate. We'll use a heat pump-led solution and phasing out completely gas plant by 2030, and developing a heat network design that is technically and commercially viable for a relatively small core scheme with low heat demand, but on the same time providing the opportunity for future expansion and decarbonizing the rest of the Nottingdale area and the Kensington and Chelsea borough. That's all. Thank you.
Thank you both very much. We're running just a little bit over time, but we do have a bit of time now to take questions from the audience. Given that we've had quite a few come through, I've tried to focus on the questions that are specific to the projects. So James, there were a few just specifically on your project. What did you do in terms of planning for the actual heat network? Did you have multiple or single applications from a planning perspective?
It was multiple applications. I managed them all, so it was a bit unfortunate, really. We tried to go in with sort of a wide-scale plan to the council up front, but because we weren't certain on various different elements, they indicated that they'd prefer us to come forward when we're 100% certain on all of the design in a sort of piecemeal fashion. So the phases more or less relate to the phases that I went through on the original plan on the second slide. So each different phase had a different planning application associated with it, and that was the way around that we did it. And then the energy centre had its own application as well.
Great, thank you. And I guess linked to the energy centre, one of the questions is around public perception and people associating the energy centres with dirty power plants. What sort of engagement did you do with the local community to prevent those sorts of feelings?
We sent a letter. Well, it was like a glossy page turner sort of thing, like a leaflet, and we posted it quite far and wide, and offered meetings off the back of it. And what we found is that there was quite a few people that were we're interested, and especially in the flats nearby. They sent like a flat leader, if you like, someone to represent all the flats, and then they just had a conversation about, you know, when you're drilling your holes to go beneath roads, is it going to shake our building up, and is it going to poison the air, and all absolutely valid concerns. But we were able to just show the data from the reports that we had submitted with the planning application to just ease those concerns and explain that, look, we're going to be taking heat from water here. We're not throwing coal into this or anything like that, and the emissions from the stat that you can see are actually the same emissions that you'd have from your ordinary gas boiler within your house. Granted, there's quite a bit more of them, but you know, it's not as dirty and polluting as you might think, given that it does look a bit like a power station with that flue. But you've just got to be you've got to be communicating the key points of exactly what it is and what we're trying to do.
Thanks, James. I was wondering if I could bring Jeff in here, sort of following on from that, whether you can provide a bit more information around your resident co-design approach, because I think that's really important to make sure the residents are brought along on the journey.
Yeah, so we've got a dedicated resident engagement manager, and it's following the same approach that we've had with the refurbishment, where residents are sort of front and centre, making the decisions on what's happening and what's not happening. So the messaging's been really important. Obviously, it's a complicated project, and some of the technical pieces, that's not what the residents are going to want to have an input into. It's all about what it really. Well, I guess there's two levels. Some residents, it's just about what does it mean for them, and what does it mean for them in their home, and what's going to be happening. There's big change as people move from, at the moment they haven't got any metering, so individual heat metering is going to be a big transition for them and helping them on that journey. And then there's other residents that really want to know about that, what it means for them, but also what does it mean for the estate, what does it mean for the environment, and providing that information in a sort of readily understandable formats. One of the big challenges, I guess, on a big complicated project like this.
Great, thank you, Jeff. I guess another one for you, if that's okay. What's the size of the heat pumps for the Nottingdale heat network, and whether you or somebody else on the panel is able to comment on how big you can go with large-scale air source heat pumps within heat networks?
That's one for Evangelos.
For the Nottingdale heat network, the air source heat pumps selected is a 1 megawatt unit. How big you can go, you can add multiple air source heat pumps. There are units up to 3-4 megawatts, but that then depends on the type of refrigerant and the temperatures you're looking to supply. But you can always go for a modular option where you can add more and more units in series, so you can supply more heat to them.
Just on that, Evangelos, what's the limit in terms of the roof space you had? You know, how big could it go?
Yeah, that for us it was. I think for the laser center, roof space available could allow us to put another probably similar unit, another 1 megawatt. But I think that is currently being investigated is the impact on the structural aspects of the roof, which it was already had some issues, that roof, so it's being reinforced to take the heat pump plant as well.
Right, really interesting. Some quite tricky challenges there, I think. So we've got about a minute left of the panel discussion. There were a few questions around counterfactual technologies. Will it change away from gas boilers to heat pumps potentially? And also around the role of hydrogen within heat networks. Wondered whether anybody wants to comment on that.
Evangelos?
Well, for the counterfactual position, that was especially on the Nottingdale project was it was a good opportunity to test that theory. So as I said, we looked on pretty much every possible scenario. So we looked on gas, which was our close to the do nothing option, but when it came to the car electrifying the heat, we looked on, as I said, on the air source heat, individual air source heat pumps solution, and direct electric heating, which is usually something that is preferred on new developments from building service point of view, because it's, especially if it is new builds. That's something that has to be treated for the individual project and try to develop it together with, I guess, with the project team and the client to see what fits better. It could be a mix of utilizing your counterfactual position. Could start with what is your existing plant, especially if it is still relatively new and can operate, so it can be gas for a few years, and then find that trigger point where it moves to the non-gas option, which can be your heat pumps or direct electric. But yeah, we need to start applying counterfactual position which looks into decarbonizing the heat. So which I guess that will also benefit heat networks in the long term when you're comparing against that, compared to what we have to deal with up to now with when it was everything against gas.
I guess it ties quite nicely into Simon's sort of earlier presentation around the different ages of heat networks and how the landscape is always changing, and we've got to be ready to adapt to those.
So, Sam, did you want me to come in?
Oh yeah.
I don't know whether delegates can see me, but hopefully they can. Yeah, I think there's different answers to that question. So if you are putting in a planning application for your building in London and you're looking to connect on a heat network, then typically the counterfactual you'll be looking at is an air source heat pump in the building. However, quite perversely at the moment, although developers are recognising that they would need to put in an air source heat pump for their building, they're not currently prepared to accept a whole life cycle cost of heat that they buy, or that the network operator sells to the residents based on anything other than a gas-fired boiler counterfactual. So there's currently a divergence between what developers are putting in as capital plan and what they're prepared to accept as a counterfactual. And I think over time that has to change as people understand the higher cost of decarbonised heat, because the problem is that the developer's just paying for the initial upfront cost for the air source heat pump, but it's ignoring the fact that there's a whole life cycle cost replacement for the air source heat pump. I think separately, if you're developing a heat network out to connect to new buildings and those buildings don't feel any pressure to decarbonise themselves, again, sadly, the problem is that they're looking at a gas-fired boiler counterfactual, and that's one of the issues for our members when they're looking to expand heat networks to existing buildings, that unless that building has a pressure to decarbonise already, then you are being compared against a gas-fired boiler counterfactual, and that's one of the issues. So there will be a transition over the next decade when people understand that comparing supplies against a gas-fired boiler counterfactual becomes unacceptable and is not the right thing to do. But we're not quite at that point yet, Sam, and it's creating a very confused and mixed marketplace, in my opinion.
Yeah, but watch this space. Thanks, Simon. So I think we've now got Sam from AECOM. We can move on to the next slide, please.
Yes, thank you. I'm Sam Shuttleworth. I'm a low carbon energy engineer working for AECOM. If you don't know us, we're an engineering consultancy providing analytical and design services throughout the whole district heating lifecycle. And we've been working closely with Worthing Borough Council now for 3 years on this specific project. We were originally commissioned to develop a net carbon neutral plan for the borough, which identified the potential for district heating across the area, especially within the town centre, as it offered, a good route, a potential means to decarbonising large swathes of the building in that area. AECOM then took on the technical consultancy role throughout the HNDU stages of work, so that's heat mapping, feasibility and DPD, and we're now preparing the tender for a delivery partner as part of the commercialisation stage of the project following a successful HNIP application. So the council's primary driver for this network has always been the decarbonisation of their buildings in the town centre. And through the analytical steps that we've taken, it became obvious that this would stipulate us to go down a heat pump route for this network, as there's no substantial waste heat opportunities in the area. And the system in total is due to connect to circa 28 buildings in and around the town centre. It's entirely public sector initially, and it's considered quite highly innovative for reasons I'll get onto later. Next slide, please. So our assessment steps took the standard route through the HNDU processes. So the first assessment was to identify all the potential sources of waste and ambient heat in the borough. Within the town centre, there were 3 standout opportunities for high efficiency heat pumps. So that's heat pumps that work over and above the efficiency of an air source heat pump. So the first of these was ground source, and this would utilise the chalk aquifer that is beneath the town and is highly saturated with water. So you know, it's an ideal source of waste heat from a water source. The second was marine water, so using the sea. So it's a coastal town, Worthing. So obviously, you know, the sea is almost indefinite in terms of its water flow, so it is a great source of ambient heat. And we also looked at sewer source heat recovery. So not shown on that map, but there is a mainline sewer running down the centre through the town. As a sort of a comparative point, we also assessed using centralised air source heat pumps and also biogas combustion. But these were discounted because they didn't offer the carbon savings that would have been available if air source heat pumps were installed individually in each building. Now, to be able to compare the technical, economic and environmental benefits of each of these 3 heat pumps, we needed to better understand some of the key quanta around each source. So that led us to looking into those ones noted on the screen there. So the amount of heat was very important. So that's how much heat you can extract from the different sources. The conditions of that heat. So what temperature is it being? What temperature is that heat source throughout the year, and how does that correspond to the heating season? So so that was quite variable, because obviously the surface water system, sources were quite dependent on the solar energy. So the sea gets cooler in the winter when you need more heat, and that's important because the sewer was found to have a far more stable temperature throughout the winter period, and that generally led to coefficients of performance being higher overall. There are also key commercial aspects which other members have spoken about already, such as land ownership issues, water body ownership issues, and sewer infrastructure ownership issues as well. There's also regulatory body stipulations. So if you're taking water out of the aquifer, then the EA get involved. If you're taking water out of the sea, then the Marine Authority get involved, and then out of the sewer again. It's just that's not down to regulatory bodies. It's just making agreements with the water operator themselves. Each system did come with quite different capital cost profiles and operational costs linked to maintenance and the fuel costs, which were directly relatable to the efficiencies I spoke about earlier. So once we'd considered all of these quanta, we drew up concept designs for each different source, and that allowed us to comparatively assess them against one another. So next slide, please. So using the design and the performance quanta I've just spoken about, we could then compare them to one another with regards to how they performed operationally, capital cost, and the thermal output. So you can see from that table down the right hand side, they are quite different to one another. So the sewer source was found to offer between 6 and 8 megawatts of heat thermal output from the heat pump, which is quite considerable, and it could all be accessed from a single location. The open loop ground source heat pumps that we looked at, they offered smaller individual installs at different locations, so we'd need more than one energy centre if we were going to go down that route. The closed loop, the outputs from that system were far too low to be considered for this network, and it was almost immediately discounted. And the marine source, as I said, almost unlimited heating potential. So from our energy analysis, we derived that we need an installation of somewhere in the region of 3 megawatts. to get the heat fraction that's shown there. But it was also very important to the council that any system we progressed with was highly expandable, because they saw the potential for the network in the long term was to decarbonise far more than just the public sector. So they were looking to involve a lot of the private sector in the town as well, which would then sort of work towards decarbonising the council's Scope 3 emissions. So then we did our whole life cycle economic appraisal of the different systems. So if you're familiar with the term techno-economic modelling, then that's what that means. And that gave us an insight into what the long-term cost implications were to all the customers on the network. So what they'd be paying for each unit of heat that they would extract in the long term, as well as the carbon performance and how low carbon the heat being delivered to them could be. Also very important was looking into the major risks of each of the different systems. So the risk profiles were quite different. When we looked into the ground source heat pump, we found that it could result in the long-term cooling of the aquifer if the flow of water through the aquifer itself wasn't suitable, and that was looking into where there were fault lines in the chalk and things like that. There were also concerns because the water table was so far above the aquifer with regards to recharging. So once you've extracted the water, put it through the heat pumps, there were concerns over how that water could then be put straight back into the aquifer. And it's all to do with pressures and things like that. And again, as I previously mentioned, it would need multiple energy centres. The risks for the sewer source solution were that it's largely unproven in the UK at this scale. So there are several installations already in Scotland, but they were at more of a communal scale rather than this district scale that we're looking at here. And at the time, all of our work was desktop based, so we were unsure of the flow rates and the temperatures within that sewer, with all of our work coming from Southern Water's modelling data. And then with regards to the marine water solution, the risks were mostly around the necessity to install infrastructure on the beachfront, which is something the council weren't hugely keen on, because obviously being a coastal town, the beachfront is its main natural wonder, and it's something they'd like to preserve. So once we'd handed over all of this information to the council and spoken them through it and made sure they understood it, etc., they went away and then they came back and they identified the sewer source heat pump system as being their preferred option, with the aquifer based one being their fallback. This is because they considered themselves quite an innovative council. They were willing to take on the technical risk that that option posed, because the benefits were deemed suitably attractive against the other options, and it's something they wanted to proceed with. However, before we could go away and take the system to sort of an OBC level, so outline business case, and into commercialization, the council were very keen on de-risking the project further from an engineering point of view. So what that meant was a lot of on-site testing being undertaken and looking at the different concept designs within the system itself. And that led us to procuring a company called Research Energy. So I'm now going to hand over to Joe to talk you through his process in de-risking the solution to enable the council to be suitably satisfied that it was the right technology to proceed with.
Hello everyone, my name is Joe Short. It looks like I've got -3 minutes, so I'm going to be really quick for Sam's benefit here. Just to let you know, I'm one of the people that worked on those projects in Scotland. I'm a director of Research Energy, and we actually own and operate an 800 kilowatt scheme, the first commercial scheme in the UK at Borders College, and there's an open invitation to anyone that wants to come and visit. So after saying that very quickly, I'm going to move on. So obviously the key aspect of our work was to get sewer monitoring equipment into the sewer that was adjacent to the energy centre in that road, as Sam mentioned earlier, up the centre of the town, and to do monitoring of flow rates and temperatures. And when I say flow rates, well, we actually measure our depths of water in the sewer and the velocity of that water. And they're very important parameters when it comes to the design of the sewer connection, which I'll come to later. kudos to the council and AECOM. They've gone for the full 12 months of sewer monitoring, which we are now just coming to the completion of, which is a really good idea, because obviously there is a lot of variation in the sewer over the course of a year. You can see just a couple of photos there of the sewer installing the kit, and on the right a couple of charts there showing variations in flow rate across a typical 24-hour period, and temperatures as well, broken down by month. So if we can have the next slide, please. The next stage is once we started to collect the data, and we actually own the kit we installed in the sewer to do the monitoring. We like to use a specific type of technology that allows us to download the data on a daily basis and avoid costly revisits to the sewer to download data. And that can make sure that the sewer monitoring is being conducted correctly, and it can give us a feel very early in the monitoring of where we are in terms of flows. So we took those flows, we did a conceptual sewer connection design, which you can see on the right there, sketched out on the right, and used that to calculate the amount of water we could actually abstract from the sewer, given different connection designs and sizes, and then use that data to actually model what size of heat pumps we could have. You can see there's a little table there with the size of heat pump down the left and the connection size at the top, and compared that to data we received from AECOM on the heat demand, because obviously it's not just about having good flows, but having flows and temperatures at the right time to meet capacity. So we modelled what was in the sewer, the flows, the temperatures, converted that into a heat pump capacity, a heat pump output, and then match that side by side with heat demand. And we also took a similar approach when calculating SCOPs for the year. Next slide, please. We also did a technology options appraisal. It's a fairly new technology in the UK, so it might surprise people to know there are a number of technology options, at least 5 I can think of at the top of my head in terms of different types of technology, and then there's a number of different suppliers. We did a mini survey and a request for information from suppliers so we could actually check costs, CapEx and OpEx costs for running the specialist wastewater heat recovery kit. And also check that the footprint of the equipment was going to fit in the energy centres and the energy centre locations that AECOM had identified. And also with a lot of this kit, it is modular, so it's very easy to scale and expand it up, which is also important, as we've heard earlier, as a district heat network and heat demand grows over time. So there's a very, very quick overview of what we did. We obviously collected that CapEx and OpEx information, fed it into AECOM, and they put it into their financial models to take to the next stage. Thanks very much.
Thank you. So I think we've got Paul next.
Hi everybody, it's Paul Barker. I'm the Energy Infrastructure Manager for Bristol City Council, responsible for delivering heat networks, and this is a dual presentation with Dave Pearson from STAR. Dave, do you want to introduce yourself? I think you've got the first couple of slides, haven't you?
Thanks, Paul. Yes, I'm Group Sustainable Development Director for STAR and also STAR Renewable Energy. Next slide, please. So, yeah, are we facing a threat or an opportunity? That's the question that we're going to pose to you. Next slide, please. Specifically, when we're looking at large district heating and heat pumps, it's all about capacity. The challenge is to decarbonise the entire country, not just pockets of it. So it's about finding something that's big. So for me, thinking about what a heat pump looks like there's several different aspects. Sam, these are auto forwarding, I think. If you can just hit the pause, I think, and we can go back to Paul's piece there. So it's about finding a heat source. Some of the speakers have already spoken to this. It's got to be big enough. Heat demand, obviously, you need to understand it, and finding that technology in the middle. Return on investment's an interesting bit, and nobody yet has mentioned the price of electricity, which we'll come back to later. But I'll hand you to Paul for the Bristol piece here. Hopefully the slides can stick on that. Sam's having a
apologies.
Tough day at the office.
Well, I've got my slides open separately so I can go through this, but it looks like okay, it's stopped. So just a quick context of heat networks and heat pumps, which is what we're doing in Bristol, is that we were the first authority to announce that it's a climate emergency and that we're looking to deliver net zero by 2030. Like many of the cities, heat and hot water represent a significant amount of our carbon emissions, 45%. And actually for the city centre and those other areas of the city with high heat demand, heat networks are really the only viable solution. And I think the key word as well is tested technology. So we don't believe individual building solutions are going to be viable in a city centre. You know, we don't think that every building can well certainly not have an individual air source heat pump on it. You know, you've got listed buildings that haven't got the structural capability of that sort of system, and we also don't think we can wait for hydrogen. We might be waiting a long time, so we just want to get on with the technology that is viable. So heat networks make sense, and as Simon was talking earlier, you know, that's the next generation, and that's our view in terms of heat networks lines up with what we had CSE do for us in terms of what do we need to do to achieve 2030. And effectively says that of our 160,000 buildings in Bristol, nearly half of them will need to be connected to a heat network, and the rest will have to be some kind of individual heat pump solution. So looks like slides are all working great. So next slide, please, Erin. Or Sam, thank you. So just say in terms of Bristol, what we do, lead a team that are developing heat networks. So we install the pipework. That's pipework on Victoria Street near my office. If anyone remember those things that we used to go to on a regular basis. Top right hand corner is a plate heat exchanger or substation that we've installed in a building that we are supplying with heat. And the bottom right hand corner is the energy centre, and that's the planning application of what the final energy centre that we're going to talk about is going to look like once it's complete in the coming months. So next slide, please. So we've got multiple heat networks that we're looking to deliver across Bristol. There's a snapshot of those, and each of them potentially where they are in the city will have a potentially a different heat solution to it. Next slide, please. But ultimately, what we're saying is that, you know, these heat networks, again, as Simon was saying previously, it's got to be zero carbon. So effectively, there is in the future, you've got to get away from gas. End of. So gas EHP has got to go. And actually, I argue that the peaking gas boilers that we're looking at needs to also to go. Bit frustrating for me in the fact that we've only recently installed a gas EHP engine on one of our heat networks, but we don't expect to replace that once that gets to the end of its life. So what we're talking about then in terms of what the heat pump, also the heat solution is on the end, it's heat pumps we've been talking today. I think the next thing we need to look at is e-boilers and thermal storage, but for peak and reserve, and then also energy from waste. Now I've said short to medium term there. I suppose the fact that a lot of energy from waste is burning oil-based material, so it's whether what comes after that you would like to see less energy from waste heat available to us going forward. Although obviously carbon storage and carbon capture and storage may be a solution as well. Next slide, please. So for us, the big thing about the heat networks is, yeah, we can install the heat pipe work, but it's the development of the heat pump energy sensors that are on the end of those pipes that I think is probably the trickiest bit of the network, especially for cities, and the fact that you're looking at installing heat networks and energy sensors in city centres that are already built up. There's already tall buildings, there's always planned for new buildings, and so it's a challenge, and so the main thing to do is utilise that HNDU funding if you've got it available, or apply for it, to really look at the energy centre options and the solutions open to you, because those key issues are around the resource opportunity. People have been talking today about air, sewer, and we'll be talking about water source heat pumps. That they all have their own complexity. That each city has their own opportunity as well, and availability for these technologies. One lesson learned for us is that don't necessarily focus on one technology, one heat pump technology for one network, and because as you go through the process of understanding and going from feasibility to detailed, there's a risk that solution isn't viable, and you need to have something in your back pocket as an alternative. But as you said previously, they are complicated, and we need to get better at developing heat pump energy centres, and we will. But the other key thing is spatial context as well, and that what is around that energy centre that you're developing. So that will have an impact on potentially the location and what kind of heat pump technology you're using. So for Bristol, we have the floating harbour. So the water source heat pump that we're installing, a 3 megawatt water source heat pump that will be it's already installed, but it will be being commissioned over the coming weeks. We see that as one of the first of many. So we see water as probably our preferred technology, and then I think this is my current order, is air as the next one, and then I think as you go down the next ones, there's more complexity. We've heard about aquifers, the complexity of those. Sewers, there's more complexity, probably as well. More fact is that we don't own the sewers, so you need to make sure that your water authority is supportive and isn't going to charge you a significant amount of heat for that wastewater. And then mine workings, kind of, I feel, right down the end there because of their complexity, and certainly for Bristol, not something we're looking to progress. So that was there's a run through then, and so Dave, I think you're next.
Thanks, Paul. Yeah, next slide, please, Sam. That's just a filler. So what gives us the confidence to say this? Well, the simple answer is we've done it. We did it 10 years ago, 12 years ago now, over in Norway. It's a seawater sourced heat pump. It's still, I believe, the largest 90-degree ammonia heat pump that's operating in the world. We're always advocating lower and lower temperatures, of course. Every degree that we can lower the flow temperature, we save about 1.5% of the running cost. But that's what Drammen needed. They've got lots of old buildings, and it's been there for quite some time. So they would, I'm sure, claim to be 2045 ready already back in 2010. So next slide, please. And that was 13 megawatts. We've repeated that. This is a project done in conjunction with Western Bartonshire Council and led by Vital Energy, and that's 2.6 megawatt heat pumps in Clydebank. Next slide, please. They're taking heat from the River Clyde. It's the Clyde estuary, so as was spoken about in Worthing, it's an infinite capacity of heat, and that project's now just building up the heat demand, and the heat pumps will deliver the primary source for that. And next slide, please. And so to Bristol, a tricky place. The floating harbour was built a long time ago, probably about 1850 or so. And it's actually a locked portion of the river to keep the level, so when the tide's out, the water isn't, if you know what I mean. The boats then float. Interesting history lesson. So what's being constructed there, you can see the water pump filtration system, the brown piece next to the river, and behind that, behind the scaffolding at the moment, and this is being updated on a daily basis. The team are on site at the moment. Will be the energy centre housing the heat pumps. So next slide, please. Probably the trickiest river we've looked at. And so some thoughts from that. We're always learning. The first piece is really, the space required. Much of the plant, incidentally, could be underground. So thinking back to Worthing, why not have an underground facility for that? Really, the key bit that needs to be close to the water are the water pumps. It's just the function of physics. You can't pull the water up too great a height. The heat pumps, of course, can be much further away because they're on the discharge side of the river pumps. And so we do ponder, what if in rivers such as London, Newcastle, etc., what if the heat pumps are actually on barges and floating on the river? That might be an interesting thing. But an interesting appraisal of this, the working fluid is really important. We're working through as an industry from CFCs that everybody knows is now banned. There's been subsequent working fluids used. The only working fluid used since 1880 consistently is ammonia, and that's for very good reason. One, it's environmentally not damaging the ozone layer or creating global warming, but it's also the best efficiency, and that is the number that will always stand out in the spreadsheet of how many units of heat can I get for my unit of electricity. Next slide, please. So the early stage appraisal piece, and projects are at different stages. Clearly, a heat pump wants to get heat at the warmest temperature possible. Data centres are a fantastic opportunity. Heat's already available plus 20. It might be plus 50 in the future. Immersed racks are incredibly interesting. Wastewater quite clearly is warmer than ambient, and wastewater treatment plants, the outfall from a sewage treatment plant is commonly used around Scandinavia, but in decreasing temperature scale. And a river looks rather ordinary and boring at the bottom. However, the capacity that's available, we've already said it's somewhat infinite if it's marine and seawater. But the rivers, London, there's probably enough capacity in the flow for around about 1,000 megawatts of heat pumps dotted along the riverbank. So big swathes of London could be connected to barge-mounted river source heat pumps. And the capacity drops as you go down. And data centres, relatively small. Some Scandinavian ones about 40 megawatts, but that's pretty small by comparison, and they're not really so prevalent in the UK. And something that's very site-specific, so cop out from me, but the convenience of which and how easy it is to do. But you pretty much know where the sea or the river is, was, and shall be forevermore. And so we think that's a major part of what we're trying to do. But to refer back to the Venn diagram that was mentioned earlier, it's about finding that blend of heat source, heat demand technology, and the return on investment. And I'll leave you with a thought. Why does it cost, or why is electricity sold into the grid from a wind turbine at £50 per megawatt hour, but when you buy it 2 miles down the road, it costs £150 per megawatt hour? That's the challenge for government. If they really want this market to take off without having to give major subsidies, I think they need to get to the crux of the problem for heat pumps, which is the price of electricity. We know they're clean, we know they work, but it's all about the price of electricity. So that's the challenge I'll throw to the room, so to speak. But that's from us. So new word for you, for opportunity. Let's turn this threat into an opportunity. If you're the tax man, you should be starting to count how much revenue you're going to make and all the tax raising from all this construction stimulus that's going to be going on. And of course, importing less fossil fuel can't be a bad thing either. So I'll leave it at that. Thank you very much.
Thank you, Dave, and apologies about the slides once again. I think we've got them sorted now. So we've got some time now to go through a few questions that have been submitted. There were actually a couple around thermal storage and whether the projects are considering centralised thermal storage, what the benefits are, and why they're suitable. So wondering, I guess, whether anybody wanted to come forward.
Can I say something very briefly on that? There's a gentleman called Henrik Lund. He's a professor at Aalborg University in Denmark, and gave a paper many years ago and built up. If anybody's seen 4th generation and 5th generation diagrams, they were his. So he is the guru in my head. He did a very simple assessment, which is the cost per megawatt hour. Of course, we have to measure it in megawatt hours of storage. A large centralised thermal store is the cheapest form of thermal storage. It's a big tank full of water. It's a bit bulky, it's a bit hard to fit in a site sometimes, but centralised thermal storage. Of course, the buildings themselves are thermal stores. We should in the future be tweaking up the thermostats in buildings a little bit higher if we want to push some heat or absorb electricity because it's cheaper, or nudge them down a little bit. So some really fascinating opportunities in thermal storage from this, but think big is definitely his advice.
Great, thank you. And I guess Jeff or Evangelos, are you considering storage for your site as well?
Yeah, that's something that I probably didn't include in the presentation, but yeah, thermal stores are an integral part of the design. So giving us that ability to flex with electricity price is really important.
Fantastic, thank you. We had a question, I think, for Bristol around overcoming heritage issues.
Yeah, so we've had to overcome a lot of issues with this particular site, and the site is where there used to be, well, the name's Castle Park Energy Centre, and there used to be a castle on that site. But actually, we did have to do a watching brief, but didn't find any archaeology, so we were okay to proceed really. But we've had the same sort of things. We had to make sure unexploded bomb, so unexploded ordnance survey. So we had to do a lot of that. So and so I think the main issue with the site is it happens to be where there's 2 culverts underneath the site. So actually the trickiest one was getting environmental approval to build over top or adjacent to those. So I suppose it's just like any other development. There's the various hoops that you have to go to. So again, it's worth kind of getting the necessary surveys done as soon as possible. So you're de-risking that project sooner rather than later.
Thank you. A question for Sam, I think, around how you propose to fill the gaps on peak days, and whether you're using a thermal store as well.
Yeah, okay. So in our design, we do have backup gas boilers, and they were located in the town hall using an existing chimney. So yeah, they'd be used for peaking demand, and also thermal stores to shift demand around where required.
Great, thank you. Just see if we've got any other questions that have come through. There's a question around whether electric boilers are pragmatic and a commercial solution to replacing gas boilers in the short term. We've mentioned electricity prices, obviously something that gets quite a lot of discussion, probably a separate webinar as quite a big topic. Anyone got any thoughts on the role of electric boilers and constraints on the electricity grid?
I suppose just a point from Bristol is that we have to get away from we're supposed to be zero carbon. So I think whether it's maybe not necessarily in the short term, but I think it's something we need to grasp. And Dave was talking about it's around the price of electricity, but it's also that we need a grid that can deal with this sort of technology being part of the solution. I mean, it will likely to be mostly for reserve purposes. But again, we need that support from National Grid and the DNOs to be able to understand. I suppose this comes where we talk about local area energy planning, is to understand how the networks are going to, and the heat pumps and so forth, interact with the grid, really, to ensure that it can deal with that sort of solutions as part of the decarbonisation solution, really.
Sam, can I add something on that? We modelled the electricity network in the centre of Glasgow for the whole city centre area, and what was quite interesting was there definitely are grid constraints the closer you get to the buildings, the transformers and so on. But on the high voltage network that runs through the city, there actually was a fair bit of spare capacity. And of course, if you've got very, very large heat pumps and you're connected to the high voltage grid, effectively what you're doing is operating within the headroom spare capacity on that grid. And the heat pumps that we've done, they can be switched off in less than a second. So a couple of interesting features come from that. One, you can start playing in the energy demand market, taking bonuses for switching off when the grid's stressed, or taking a bonus for switching on if the grid's a little bit surplus. The worst thing I see around the country is wind turbines on a windy day not spinning. That's basically because there's not enough flexible electricity demand. So in Glasgow, what we saw was there was capacity in the high voltage network, and that gives an opportunity to play in that space. And that's part of the cost as to why electricity goes from £50 to 150 or £200 per megawatt hour, is this averaging pricing effect to cover this peak pricing aspect. But if you're buying electricity differently, then there surely should be a different price for it. So it'll be interesting to see what happens in the coming couple of months. Other countries that I see around Europe are already doing preferential pricing for heat pumps. That to me is the simplest, easiest way for the government to make what they've picked as the right technology stack up. To Simon's earliest point in the whole session, heat pumps do not stack up post RHI without some form of other support mechanism. The easiest thing to do is to fix the problem with them rather than trying to play around the edges, and that is the price of electricity for these exceedingly low carbon devices. We will see carbon footprints down at 10–15% of burning gas for any of these heat pump schemes that are projected. And it's the easiest way to fix that problem, is fix the price of electricity.
Thanks, Dave. Because of time constraints, I'm not going to put Shivali on the spot to respond to the comments around incentives and pricing, but hopefully something to take away. I'm going to hand over to Andrew just to sum up and close.
Thank you, Sam. So that's been a fabulous nearly 2 hours. I was conscious when we were planning this that we might be a bit optimistic to get all those amazing projects summarised in a relatively short time, but the panelists, the speakers, have done really well to shed so much information, and we realise, of course, that we've got an amazing, well, it's a really big challenge, but also I think, as you'll all have heard, a great range of people trying to solve some of these problems. So I'd like just to summarise back for everybody in terms of what we've been hearing about. Obviously, so we're in a world in which heat pumps are becoming a much bigger part of the market, and we heard first from, following my introduction, from Shivali setting out some of the issues around, not so much issues, the policy drivers from BEIS, the range of important interventions that they're taking to bring about change, that through HNIP and through the other schemes, we have a great opportunity to learn and to build on those and to take things forward. I felt also interesting that, notwithstanding that there's a long track record of using heat pumps, as we heard from Dave, but there is scope for improvement. These systems can continue to get better, perhaps particularly in the way we use them, the way we control them. Moving on, we had an excellent explanation of the circumstances, why we're in the position we're in, from Simon, from his experience and an experience of his UKDA members around where we're at now. This has helped us to flesh out the range of the challenges which the sector's seeing, particularly and fundamentally about finance. This is a big dimension here of making these things work in a way that's economic for everybody. We can't have subsidy in a series of programs indefinitely. We need to create a structure in which the right systems can be built out, and I think that was a really good place to feed in. And then we've heard from the four different schemes, as I expected, a fascinating group of projects, really insightful lessons. You will all, I'm sure, have taken slightly different things from each, but for me, just running through James from Innovate and the Liverpool story, the challenge of evolving a scheme, the way they've approached it in terms of modularity, seemed really interesting to recognise that things change and to be able to be flexible and adapt. And that modularity is a key thing as part of the solution. Then moving on, we heard from Jeff and Evangelos about the Nottingdale scheme, an area where obviously needing this, well, all part of a really deep energy retrofit, which to me is a critical part of this. There were some questions we didn't have a chance to address, but actually we need, as part of the solution, is to think about the total cost of heat, not the unit cost of heat. If we're in a position whereby people can receive genuinely affordable heat in total over the whole year, the fact that the unit cost may be relatively high, we need to be able to overcome that if we're able to deliver people genuinely affordable heat in the round by diminishing those demands. I think that's a key part of the process, and I think part of the essence of the solution there. I was particularly interested in the work being done there in terms of engagement as well, that it's something I think can easily be forgotten, and it looks like an exemplar of how to go about that, and I'm sure others can learn from that process. Moving on, we heard from Worthing, and what I think is particularly striking there is the concept of the whole town decarbonisation plan, and the rigorous way that the whole community has gone about setting out its approach, and the way they've then evaluated their options, and the intention now to proceed with the sewer water heat pump. And quite a few of you will know they chose not to speak about it because this was a technical presentation, but they're also doing some interesting things in terms of procurement to see how that plays out with the way they're planning to have a concession arrangement for building out that scheme. And no doubt some of the people on this call will have joined the soft market testing session the other day and will know all about that. But again, the scope for innovation technically and the scope for innovation in how we make these projects happen. And the last project we heard was from Bristol, a range of exciting things going on in Bristol, as you'd have gathered, and really insightful again in terms of the need to take different approaches in different parts of the city. The challenges are, and we can all learn from each other, but we all need to take account of the specifics. But also in that situation, as in others, the opportunities for innovation and the things that Dave was talking about, why we need to be building. I hadn't thought of the barges idea as a solution to this, which is which could bring benefit in the right situations. And I was also noted at the end there, my last point underlined that costs here are political, and there's some really big decisions and swings to make in the entire environment here. However, we can all make a lot of progress in the meantime, whilst the political things are resolved, whilst the zoning is implemented, to make sure we're all ready to exploit these opportunities as we go forward. So my closing remarks, I'd like to thank all of you for joining and your excellent questions. We will endeavour to respond to more of them after the event. As you'll imagine, when we're speaking, it's not always easy to give fully considered responses. We'll try to respond to some more, but also to plan those, as we said, into future events. I'd like to thank my colleagues from GemServe for organising the event, all the behind the scenes stuff. But most of all, I would like to thank my fellow speakers, extremely valuable and insightful contributions to our debate. I'd like to wish you all luck with your future endeavours, and we hope to hear more and more about the success of these schemes. We're beginning to see the schemes coming into operation. Paul mentioned that the first of the Bristol schemes will be going soon, so will be even more exciting opportunities to share more with you in the future. So at that point, I think we should draw this to a close, and thank everybody again for being here, and speak to you all again before too long. Thank you, everybody.